I want to look at here the exceptions of using the tabular form or the regular form for doing integration by parts. And the first exception for integration by parts has to do with the natural log. And so let me kind of show you a little bit of a versus here before I get started with it. I want to look at here the integral of the natural log of x over x with respect to x versus the integral of x times the natural log of x with respect to x. And if we have a natural log function, there are only two ways that we can integrate it. The first would be with the u substitution. In that case, we'd have to let u be that natural log function, the whole function, whatever power it's being raised to, whatever. And then we would need our u prime. Let's look at this first example here, and let me just rewrite this a second as 1 over x times the natural log of x. And we can see here now that a u substitution is going to work out very nicely. This is going to be the u to the first, choosing u to be the natural log of x. And then what is the derivative of the natural log of x? Well, it is 1 over x. So my u prime is sitting right here. And when I integrate u to the first times u prime, I'm going to get 1/2 u squared plus c. And so putting in my x, so this is going to give us 1/2, putting in our u, natural log of x quantity squared plus c. And then just as a reminder here, the natural log of x quantity squared does not equal the natural log of x squared. They are not one and the same. This first one, I take the whole natural log of x, put that in a calculator, and then square that result. In this second part, I'm going to take the x, square it, and then apply the natural log. But just a reminder that the natural log of x quantity squared does equal 2 times the natural log of x. We need to remember our properties there. Okay, so that's the first example. And again, anytime we see a natural log of x, we're going to try that u substitution. In this second example, we're going to have a problem here because if we let u be the natural log of x, I don't have a 1 over x. As a matter of fact, what I have is extra x's. And so what I wind up with is two separate and distinct parts that cannot be combined. That means we need to do an integration by parts. When you're doing this, the table will not work in this case. You're going to have to do this the long way, and I'll show you why that is. I'm going to start by picking my u. Now in this case, I don't want to pick the u the way I normally do, and I'll show you why. If I pick the u to be x, that means that the dv would have to be the rest of this, which is the natural log of x dx. Well, here comes the problem with this. To calculate v, I'm going to need to integrate this. And how do I integrate the natural log of x? Well, without a u substitution, I can't. So that's not going to work. We're going to have to pick it exactly opposite. So when you have to do an integration by parts with a natural log of x, you're going to let u be the natural log of x. Then dv is going to be everything else, which is going to be the x dx. Now let's see how this works. Remember, what we're looking for in the integration by parts is uv minus the integral of v du. So we've got our u. Let's find our du. The derivative of u with respect to x is the derivative of the natural log of x, which is 1 over x. Then multiplying both sides by dx here, I get that du is equal to 1 over x dx. Next, we'll find v. v is going to be the integral of our dv. So that's the integral of x dx. And when we integrate that, we're going to get 1/2 x squared. Remember, you don't need the plus c till the end. So remember how we're doing this. When we look at our integral then of x and natural log of x dx, what we're looking for is u times v, which is going to give me 1/2 x squared natural log of x, and I'm going to drop down here since I don't have a lot of room, minus the integral of v, which will be 1/2 x squared times du, which is 1 over x dx. And I believe that this second integral here will clean up quite nicely. And so I get then that this will be equal to, bringing down my 1/2 x squared natural log of x, the let's see, I just wind up with just a single x in there, don't I? So that's going to be a negative 1/2, and when I integrate x, I'm going to get x squared over 2, or another 1/2 x squared plus c, looking like I'm going to get 1/2 x squared natural log of x minus 1/4 x squared all plus c.